Hey everyone, I'm Adam Kelly. We are really excited to announce that the course that we launched a little while ago, 3D rendered data sets with Blender for beginners, is now going to be launched for free on YouTube. So you will be able to watch all of the videos for free on YouTube. And then if you want the downloadable content for the course, you just have to support us on Patreon. And we want to thank those of you who are already Patreon subscribers. It means so much to us that you have chosen to give us a few dollars to support our work. So we're going to launch this over the course of multiple parts. So keep an eye out for the playlist, and any downloadable content links or links to other resources or whatever else you might need, those will be in the video description. We hope you enjoy.
If you haven't saved your work in a while, now would be a great time to do that. In this video, we're going to start talking about scripting, and sometimes scripting can take Blender to places that cause it to crash. So it's a good idea to save your work often, especially if you are fairly new to writing scripts. There's a chance that you'll write something that ends up crashing Blender and you wouldn't want to lose any work. So to start scripting, we're going to go to the scripting tab here. And what I want to show you really quick is that we've got the same scene here, and we also have a few new windows here. And these are completely customizable, by the way. You can move these around, you can close them, you can replace them with different windows. All of this is fairly easy to do, but I'm not going to do it here because we don't really need to. I just wanted to mention that that was there, and you can probably find it in the manual if you're curious. This is the Python console, and you can see right here, it is an interactive Python console using Python 3.7. So this is a very up-to-date version of Python, so it contains all the nice features that we can use to our advantage. And this right here is actually a place where we can write scripts and run them. It's technically just a text editor that you can also run as Python scripts. And so to create a new script, all you have to do is click New, and now anything you type here, you can click play and it will run as a script. So hopefully you're not completely new to Python. I think it'll be a little bit overwhelming to follow along with this whole thing. I'm going to do my best for anyone who's maybe not new to programming but is new to Python, or has just kind of dabbled in Python, kind of has the gist of it. I'm going to do my best to keep this, low level enough and explain it enough that you can follow along. So one of the first things you ever learn in Python is hello world, and I'm going to show you two different ways that you can run that script. So print, and then in parentheses, make sure you do either a single quote or a double quote, hello world. And then hit enter, and it repeats that line to us. Just a quick tip, if you're typing in this box in the console and the keystrokes don't seem to be working, it's probably because your cursor is not hovering over the console. So make sure that wherever you want to type, that your mouse cursor is in that same box. We can do the same thing here, print hello world, and we can run it. And as it says down here, it just did run script, and it's a green check mark, so it seems to have worked, but where is this output? Well, in order to see the output, you actually need to go to Window, Toggle System Console, and then this is the sort of background console that's showing all the things that are happening inside of this file. So you can see all the times I saved it, and then also the output from here, hello world. Now, you may not be 100% confident that this one didn't cause this to show up, so let me just show you really quick. I'll do hello world 2, and I'll do hello world 1 over here, and just show you really quick that it is in fact hello world 2 that shows up here. So might be a little confusing that it doesn't, go to the same place, but hopefully it makes sense. So in Blender, my general workflow is test things out here, and then use them over here. So when I'm testing things out, sometimes it's not always obvious to me what I should be using. And sometimes while the documentation for Blender is great, it's not going to tell you everything you need to know. And I just want to show you really quick. If you're on the Blender support page, there is this Python API reference, which is incredibly useful. I've been using it to sort of figure out how to make a lot of these things work. They've got a quick start guide, and then if you want to know how something works in the Blender API, this is where you want to go for it. So just wanted to point that out. So in order to access just about anything in Blender's Python library, you need to use this BPY. And I assume this is short for Blender Python. And then you can do BPY dot something. In our case, we want context dot scene. And this basically gives us access to things that are in the scene. And we're going to start off by looking at dot objects. So then hit enter, and you'll see that something came up. So not an error message, which is nice. If you just sort of type in some garbage, you'll see the difference between an actual command and a not a command. You can also hit the up key and down key to sort of cycle between the different things that you just typed. The objects is basically a container of different objects in it. If you type in square brackets and then a 0, and actually you may be struggling to see this. Let me see if I can make this a little bigger. Hopefully that's easier to see. You can hit enter, and it will give you the object that is at position 0. And that is actually this light right here. So we can do the same thing. Oh, also, I just hit a key and it warned me something. If you don't have your mouse in the right box when you're typing here, your keystrokes will not go into that box. Like if my mouse is over here and I type, it goes over here. But if my mouse is over here, it goes over here. I didn't have to click. So just be aware of that, because I get caught on that all the time. I'll click here and then I'll toss my mouse over here to get it out of the way, and then I start typing and then it doesn't work. So you can access any of the objects in the scene either by their index, or you can just type in like this, A, and now we have access to this object right here, which is why we wanted to name these exactly the same. So what can we do with this object? Well, we can do just about anything that you can do through the non-Python interface with Python. So if you can, change the color of this, if you can change the rotation, you can do all of these things with Python. And it can be a little tricky to figure out exactly how to do these things. So there are some tricks. One thing right here, if you go over here and you change the rotation, I'm going to change the Z rotation really quick, and then Control Z to undo that. Go back to scripting, and you can see a little hint down here of what was changed. So see this bpy.context.object.rotation_Euler2 equals this value. So that was because the thing at index 2 was changed of the rotation Euler. So that kind of gives us a hint at what we might want to change if, for example, we wanted to change our rotation. So what I'll do here is hit dot. And I want to show you really quick, if you start typing in a word and you're not 100% sure on what your options are, you can hit tab at any point. So I could do this right here with just after the dot, and it gives me in green all of the different things I can type. But if I'm pretty sure that it starts with rotation, then I can do ROTA, whatever, hit tab, and then it suggests all of my different options. So I want the rotation Euler, and then I'll hit enter. I just had to hit tab to auto-complete that, by the way. And now it shows me there's this object called an Euler object, and that's basically just an XYZ rotation. So it's a rotation around the x-axis by this much, a rotation around the y-axis by this, and z by this. And it's specified that this is the order that you apply them in as well. So it'll do this rotation first, then this rotation, then this rotation. Now 1.57 is actually 90 degrees in radians. And just to show you that really quick, if you do pi times 90 degrees divided by 180 degrees, that's the conversion. That gives you 1.57. So that's what that value is. So what we'd like to be able to do in a script is set this value. So let's go ahead and hit up twice on your arrow keys, pull up the rotation Euler again, and we're going to set this to something. And in order to set it, we need to tell it Euler, and then we need to give it an XYZ coordinate. And as you can see here, this is actually in, it's in parentheses right here. So make sure you do that here. It's a tuple. So we're going to rotate this, and let's just zoom in on it really quick so we can see it. And I'll hide B and C. So now we're going to rotate this, and we will keep this as this value right here. So it'll be pi divided by 2, if I'm just going to factor that really quick. And then let's not rotate it around the y, but let's rotate it around the z-axis by maybe the same amount. So I'll do pi divided by 2. Okay, so now this is a new rotation that we're telling it it's going to have. And then we need to also say XYZ, end this parenthesis, and then hit enter. And you can see that the rotation changed. So this is sort of the way that we're going to be able to modify objects in our scene. We'll figure out what the script is that will change it, and then we're going to write code over here that will change this. In this video, we're going to work in our text editor and write a Python script that will change the rotation for us automatically. So we'll delete the print statement that we already have here, and we're going to start with some import statements. So we're going to import BPY, import math, import random, import time, and then we'll say from math utils import Euler and color, and from pathlib import path. And just as a brief description, BPY is the Blender specific API. Math, random, and time, if you've done any Python programming before, these are pretty common libraries for math and generating random numbers and for getting the time. Math utils, this is going to help us with our rotations and for colors. And pathlib will help us with doing system paths, so accessing files. Now we're going to write our first function. We're going to call this def. So def, if you're not familiar with Python, is how you say, I'm going to define a new function. So def randomly underscore rotate underscore object. And we're going to just pass in an object that we're going to randomly rotate. So that variable is going to be called obj underscore to underscore change. Then end this with a colon. And then on the next line, make sure that it's tabbed in 4 spaces. And we're going to add a comment really quick. So we're going to say applies a random rotation to an object. Then on the next line, we're going to define a new variable called random underscore rot equals, and then we're going to create a rotation that is in a tuple form. So I'm going to do this in parentheses, and we're going to define an x, a y, and a z. So what we want here is basically something in radians, a random rotation. Now 360 degrees is equal to 2 times pi radians. So we want to get a value between 0 and 2 times pi. So to do that, we'll generate a random variable, random.random, with parentheses. This generates a random variable between 0 and 1. And I'll just show you really quick down here. If I import random and say random.random, we'll get a random variable, and that's a random number between 0 and 1. So we want to multiply this by 2 and then multiply it by math.pi. And that is our new x rotation. Now go ahead and copy this, put a comma, paste, comma, paste. So now we've got a completely different random x, y, and z value. Then we just need to set the random rotation on that. So we're going to say obj underscore to underscore change dot rotation underscore Euler equals, and then we need a capital E for Euler to create a new Euler rotation object. And then in parentheses, actually, sorry, we don't need the parentheses because we already did it up here. We just pass in our random underscore rot, comma, x, y, z, and then end that with a parenthesis. And now we've got a function that's going to automatically rotate an object. So let's do it with the b this time. So we will do b, and we will set this. I'm going to actually visualize it here so we can see the color too. We're going to say randomly rotate object, and we want to pass in this object right here. So we want bpy.context.scene, and we're going to say .objects b. Okay, and I just realized that this is probably a little small, so I'm going to try and make it a little bigger. I don't want it to go off screen, so maybe I'll try to grab this here, make this a little bigger. There. Okay, hopefully that is a lot easier to see. I'll give you a sec. You can pause the video if you needed to catch up. I apologize that I didn't catch that a little sooner. And then we just need to end parenthesis this, and if this worked correctly, I'm going to save it really quick. I should be able to hit play, and it applies a random rotation. And we can run this as many times as we want. There's nothing wrong with it. It applies it immediately. So that's pretty cool that we now have this function that will randomly rotate it. So this is helpful. What we're going to do is run this function before we render a new frame so that we can generate infinite random rotations here. And you can also check down here, if you did have an error message, this is where you would go to look. So just remember, if you ever lose that, it's that toggle system console, and that is going to help. I'll also mention that if you run Blender from the command line to begin with, like you go to CMD and you run blender.exe, then you won't need this toggle system console because that console that you ran it from will act the same way that this one does. So just a little hint there for you. So that wraps up this video. In the next one, we're going to move on to changing the color of this object. In this video, we are going to write a new function that randomly changes the color of the object. So let's add a new function after our randomly rotate object function. And we need a def, and then we'll call it randomly underscore change underscore color. And we're going to pass in a material underscore to underscore change. So we're going to make this a little easier on this function. We're going to tell it what material we want to change. We're not going to just directly give it an object, but we will give it a material. Put a colon, and then on the next line, we'll add a comment here. So 3 double quotes, changes the principled BSDF color of a material to a random color. And then 3 more double quotes to end that. So we are going to change on the material of this object, we're going to change the principled BSDF base color. So the first thing that we need to do is actually add this here. It looks like I already did it, but make sure to go up to the line that has from math utils import Euler add a comma, and then a capital C and then the word color. We need this in order to create a color object. So we're going to define a new color. We'll call it color in lowercase equals color in uppercase. And that might be a little bit confusing, but the color is the name of the data type, and the uppercase color is the name of the data type. The lowercase color is just a variable name that we chose. So we could call this whatever we want, but this one has to be specifically color for it to work properly. Now we're going to define the hue of this. And just to show you really quick, if we are in RGB, red, green, blue, we can modify the colors, but in order to do so, we can't just pick random values. If we just chose like maybe a few random values like this, then we'd end up with a light color like this. And what we're going for, I mean, there's nothing technically wrong with that. It still is an interesting object to find, but I was hoping to do something more around the outside of this curve, so like bright colors. And I'm a little embarrassed to admit that when I first tried to implement this, I wrote a function that would modify the red, green, and blue values to cycle around this. And it was a pretty complex math equation involving sines and arc sines and clamping things. And so I initially did this code with that, and then it turned out there is a much simpler way to do this. And that is to use the hue saturation value. Well, if you have the saturation all the way up and the value all the way up, you can go around the edge of this circle just by changing the hue. So what we're going to do is set a random hue somewhere along this between 0 and 1. So that's pretty straightforward. So we're going to say hue equals random.random. And this is a random hue between 0 and 1. So we're just defining this variable. And then all we have to do is set the hue of this color. So color.hsv. I tried setting the hue directly, but that didn't seem to work. But if you set the .hsv value, it does seem to work. So hue, 1, 1. So what we're saying is pick a random hue and then set the saturation to 1 and the value to 1. Then we're going to convert this into RGB. So we'll just say RGBA equals, and we're going to create a new list here. And we're going to do color.r, color.g, color.b, 1. So that last one is the alpha value. And then we just have to say, I'll just copy this, material to change dot node underscore tree dot nodes. And then we're going to pass in principled BSDF dot inputs 0 dot default underscore value equals RGBA. So we're passing in this color now as the default value. Now, how would you have any idea that this was what you were supposed to change that color? Well, this gives us a hint. So as we were changing this color, I want you to take a look. Right now it says it's 100. If we change this to this other hue right here, you'll notice that it shows that we changed something down here. And what are we changing? Well, we're changing our letter material .node tree .nodes principled BSDF .inputs 0 .default value. And it just sets it to an RGB alpha value. So that's what we're doing with this function. And we can test it out. So what we will do is we'll say randomly change color, and we'll pass in the material to change. And just to make things simple, we'll just do bpy.data.materials, and then we'll pass in letter material. And then make sure to close off the parentheses. And that is basically just this first part. So we're getting that material, and then we're going to change the color of it. So if we save this, so I'm just going to save this file really quick and click play, Oh, looks like something went wrong. Let's see what it is. So let me look in the console here. Python script failed. Let's see, line 19, tuple object is not callable. So something here, oh, I forgot the equals sign. Maybe you did not miss that. Maybe you saw it and hopefully you caught that. So I'm going to save it and try running again. And now you'll notice that it picked a different color and it rotated the object. So I can play this as many times as I want, and it's just going to keep picking new colors and keep rotating the object. So we've got these really helpful functions. Now what we want to do is run this, a few hundred times and render these out to a file. In this video, we're going to talk about rendering, and specifically rendering from a Python script. If you're a normal Blender user, you probably just use the render menu and you click render image, and then you get an image that was rendered. And this is the render result, which is actually not what we want right now. We would rather that all the letters don't show up at the same time. So let's go ahead and close this and we will fix that issue before we start rendering from script. So we have hidden A and C in this case using this little I symbol here. If you go into the filter menu and then you click on this disable in renders little camera icon, then it shows you what is visible in renders. So if we hide this one, and then we render again, then we'll get just our object, which is what we want. So that's something we're going to have to do in script as we're automating this, but not in this video. We're not going to worry about that. We just want one of them visible for now. Now, by default, this render doesn't actually save any images. It's a little maybe misleading, but if you render it and you just want to save the image, you have to go to Image, Save, and that's a lot of work. We don't want to do that 1,000 times for every single different letter. So we'll be able to do that automatically from the script as well. But I just wanted to show you really quick in the, let's see, Output Properties tab here. There's an output section that shows you where this is going to go. So this TMP directory is the default for Blender. And on Windows, that means the C:/TMP. So I've got a bunch of stuff in here that I've rendered from different projects and this project as I was working on it. So you probably won't have anything in here unless you've done some rendering prior to this. But what we need to do is edit this path from the script, and then we need to call the command that renders from the script. So let's take a look at what that is. So what we need to do is figure out what is this path. And I just clicked on it. So it shows up here or I just edited it actually. That's why it shows up here. This bpy.context.scene.render.file path. That is what we want to change. So we can actually set that here. bpy.context.scene.render.file path, and it's just a string. So we will give it, I'm going to actually give it an explicit path here, :/tmp/, and I'm going to call this abc_test. And not only this is that's the directory, but we need to give it some sort of file name. So I'm just going to call this test render.png. And then the command to render is bpy.ops.render.render. And we need a parameter called right_still equals true. And what this does is it saves that still image that it rendered to this path. Okay, so in ABC test, I believe I may have actually run a test run here. So let me clear this out. So empty folder, then if we hit play here, then it will kind of hang the UI for just a second while it's rendering, and then our rendered image shows up here. So this is rendering that exact shape from the camera's angle. So it might look a little different if you're not viewing it from the same angle as the camera. But that is the basics of how to render an image from a script. Now, we want to be able to render every different type of object multiple different times, and we want to automatically update these file paths. So we have quite a bit of work still to do in order to do all of this automatically. But what's nice is you can see that you can render out several of these just automatically. It's overwriting this each time, but it's changing, it's randomly rotating the object, randomly changing the color, and then it's setting the file path, and then it is writing this out as a file. In this video, we're going to start writing the main portion of our script that's going to loop through a bunch of different things that we want to render. Typically, when you're training artificial intelligence, neural networks, you want a training data set, a validation data set, and a test data set. So we want to have all of those, and for each one, we need examples of A, B, and C. And for each one of those, we want, 100, 200, 300 different images. So we're going to do a loop that's going to go through all of those different combinations. And before we can do that, we need to have a few variables that are going to help us out. So go ahead and remove these. You're welcome to keep them commented if you want them for reference, but I'm just going to completely remove them. And then here underneath this function, but not in the function, so make sure you're at the edge of the line here, we're going to make a couple new variables. Object names to render is basically what these are. So we're going to say obj_names equals, and then we're going to create a new list. So do square brackets, and we want a capital A in quotes, B, and C. And what this is a list of the objects that we're interested in rendering. So we have A, B, and C. Make sure that your names match up here. That's important. If they don't match, then this will not work. And then we're going to do obj_count equals, and we're going to use the len function. Then we're going to just pass in obj_names. So this will tell us how long this list is so that we don't have to manually write 3, or if we add more classes, we don't have to do a bunch of, it's not that much work, but it's easier. So this next one, we're going to create a variable that's called essentially object renders per split. So we'll call this obj_renders per split, like this. And we're going to set this equal to a list of tuples. So these are basically pairs of, and we're going to call this first one train in quotes, and then the second value is 3. So these will be pairs of the folder that we're going to render into, and then how many of each object to render. So we're, in this case, let me just add a couple more here and then I'll talk a little more about it. Val 2, and finally test 1. So make sure you have your rounded parentheses here and then your square brackets around the outside, and then you have commas in between. And what this is basically just a bunch of pairs. What this is going to ultimately tell our code to do is create a train folder that has 3 images of A, 3 of B, and 3 of C in it. And then create a val folder with 2 of each of these, and then a test folder with 1 of each of these. Now, you may be wondering why these numbers are so low, and that is because we are going to test this out on a small number of renders before we kick off a render that's going to take an hour, or hopefully not quite an hour for this data set because it's a lot lower resolution. But it's good to test with a small number before you kick off something that freezes the Blender UI and ends up forcing you to close Blender. So I'm going to add a quick comment here to describe what this is doing. So just as a recap, this is the number of images to generate of each object for each split of the data set. And as an example, if you do 100 for a folder called train, it means generate 100 images each of A, B, and C, resulting in 300 total training images. All right. Now, ultimately, we're going to have much higher counts for these, but we'll come back and add those later. The next one is going to be the output path. And we'll just call this output underscore path. And we're going to set this equal to a path. Okay, we're using the path module from the pathlib class because this is just a better way of managing paths. It works better across platforms, so Windows, Linux, etc. And it also makes it easier to append paths and do other functionality that strings just don't provide. So I'm going to pass in a direct path to where I want this to go. So I'm using Windows, so I'm going to say c:/tmp/abc_test. So this is going to go into my test folder right here. If you're on Linux or Mac, make sure that you omit the C and that you pass it wherever you want this to go. It doesn't have to go in the temp directory. It's just a convenient place. And then the next one we want is total render count. So we need to have some way to know how many of these images are going to be rendered. The reason we need that is we would like to output what progress we've made so far. So we'll be able to tell, we're on image 1000 out of 3000, for example. So to do that, I made a little one-liner that's maybe a little difficult to follow, but I'm going to write it out and then I'll explain what it is. So first of all, it's a sum. So we're going to add up all of the things that are in this list. And we're going to create this list. It's going to be obj_count times R1, so R of index 1, for R in obj_renders_per split. Okay, so we're taking this right here, we're looping through it. Okay, so for R in obj renders per split. So right now R is equal to this, assuming that we're looping through it. R1 means this value right here. So this is index 0, so this is R0, this is R1. And we're going to multiply this by the number of objects, so object count. So in our case, we have 3 objects times 3 because we're creating 3 renders per object for the training. And this is going to result in a list. I'll just show you really quick. So essentially, we're doing the sum of a list. And this first one is going to be 3 times 3 equals 9. The next one is going to be 2 right here times 3 is 6. And then the last one is 1 times 3 is 3. Okay, so our total number of renders is the sum of all of these values, which is 18. So that's what this is right here. And I'm just going to add a quick comment to describe this. All right, so just as a recap, for each dataset split, we're going to have train, val, and test in our case. There's nothing that says you can't do other ones. You could also do all training or leave off the test dataset. You just decide what it's going to be up here. Multiply the number of renders per object by the number of objects. So we have 3. And then compute the sum. So that's all we're going to do in this video. Those are just a few things that are going to help us while we're looping through. And in the next video, we'll come back and we'll keep working on this. In this video, we're going to start looping through our objects and start basically creating these loops that are going to do the work for us. So the first thing we're going to do is set all objects to be hidden in rendering. Now, we have manually hidden A and C right now, but it would be nice if we had something that automatically showed the one that we wanted to render. So the first thing we're going to do is just hide them all, and then we'll show them all as needed, or show them one at a time, I should say. So for name in obj names, so we're going to loop through this list right here. We're going to say bpy.context.scene.objects name, so we're looking up the object for it, .hide_render equals true. Okay, so we're just saying hide it. That's all we're doing in this. Pretty simple. Next, we want a new variable that tracks the starting image index for each object loop. So this is going to help us with our counter to tell how many images we've rendered so far. We're going to have start underscore IDX equals 0. So after we've gotten to a certain point, we're going to update this start index. And this will make more sense in a moment. Then we're going to keep track of start time in seconds. Start time equals time.time. And this will allow us to estimate how much time is remaining. So let's start with our first loop. We're going to loop through each split of the data set for split underscore name renders per object in obj underscore renders per split, just like that. So this right here is this list right here. So we're basically looping through this list and grabbing the split name, which will be either train, val, or test, and the renders per object, 3, 2, or 1 in our case. And let's print out something so that we know while we're rendering this where we're at in the process. So we're going to print, and we're going to use f so that we can format this string. And I'm going to close this off just to make it a little easier. Starting split colon space, and then in curly brackets, we're going to say split underscore name. So we're going to pass in that variable split name, so like train. And then I'm going to use a bar like this. You can use whatever symbol you want, but I guess, or maybe it's called a pipe. It's right underneath my backspace key, right above my enter key. And then total renders, colon. And then I'm going to pass in renders per object times obj count. So this is the total number of renders that we're about to create for this. So basically it's just 3 times object names is 3. So we're going to get 9 in our case. If we had a lot more renders, we'd have a much bigger number there. And then we're going to print out just sort of a dividing line. So I'm going to print out just a bunch of equal signs here. Doesn't really matter how many you do. It's just going to help make it a little more visually obvious where we're at. Next, we're going to loop through the objects by name. So we're going to for obj underscore name in obj underscore names, colon. And we're going to do something similar. So I'm not going to copy it. That's too lazy. All right, print f colon, or sorry, f, and then we're just going to close off the quotes and then do parentheses. We're going to say starting object, colon, and we're going to do split underscore name, end curly bracket, then a slash, and then a new curly bracket, obj underscore name. So the slash doesn't actually do anything, it's just for visuals, but we're gonna give the split name and the object name. And then we're going to print another sort of dividing line, so I'm just going to do a bunch of dots here. And then what will happen is we'll go through all of these. So actually, if I do this right now and I make sure that my window's open like this, if I hit play, then it ran the script. I can take a look, and you can see that it starts out by saying starting split, total renders 9. Then it does train A, train B, train C, then val A, val B, val C, test A, test B, test D. Okay, so that is what these loops are starting out with. And then inside of here, we're going to actually get our object. So we're going to get the next object and make it visible. So just like we made these invisible, we're going to say obj underscore 2 underscore render equals bpy.context.scene.objects, and then we have to pass in the obj, whoops, not in quotes, obj underscore name. Okay, so we're looking up the object, and then we have to say obj_2_render dot hide render, just like this, equals false. Okay, so now it's going to hide all of them. That's all this script is supposed to do. So then we can add our final loop here. We'll say loop through all image renders for this object. Okay, so we'll say for I in range, and we're going to pass in the start index, or IDX. Okay, so this is the number of the image that we're starting on. So we'll start at 0 because this is set to 0. And then we're going to go up to start IDX plus renders per object. Okay, so in this first case, it'll be 0. And then what we'll end up with is at some point it'll set this start index will be 3 because we're going to increase it. And then this will be 3 plus renders per object. So we'll be rendering images 3 through 5, 3, 4, and 5, and so on. So that's what this loop does. And then I'm going to kind of skip over the things in here. For now, we're just going to print out rendering. Maybe, actually, let's just print out I for now. And then outside of this loop, so after the for loop, make sure you tab back. Then we will say start underscore IDX plus equals renders per object. And the point of that is to update the starting image index. So basically, we're just going to make sure that this counter kind of keeps going up. So if we save this and run it, then if it worked properly, oops, that's wrong. So if it worked properly, then we'll have 3 different printouts, one for each image in the training data set. So 0, 1, and 2 are going to be processed first, then 3, 4, and 5 are B, then 6, 7, and 8 are C. And then we're going to switch to our validation set, and then images 9 and 10, 11 and 12, 13 and 14, and then 15, 16, and 17 for a total number of renders of 18. So now that we have our loops in place, we can come back in the next video and start filling in what we actually want to do inside of these loops. And if you haven't been saving along the way, go ahead and save it, and then make sure you don't lose any of your work. In this video, we're going to fill out the rest of the contents of this loop, finish up this script, and then we can test out the rendering. So in here, as you might have guessed, our goal is not just to print out an index. We wanted to do a little bit more interesting work with this script. So let's remove this print statement, and we're going to, first of all, change the object. So what do I mean by that? I mean, let's take advantage of these functions that we wrote up here where we randomly rotate the object and randomly change the color. So we're going to say randomly rotate object. And what do we want to pass in? Well, this obj to render. So we can pass that in. And then we want to randomly change color. And remember, we were passing in a material here. So we need to get the material of the object to render. So we're going to use obj to render dot material underscore slots 0 dot material. So that is how you get the material on an object. And we can show it. You can test this out over here if you're curious, but that's just the shortcut way to do it. So now each time we loop through this, we'll randomly rotate it and change the color. Let's output some status really quick. So we're going to log status, and the status will be print f, and then 2 quotes there, and we're going to say rendering image I plus 1 of, and we're going to say total render count in curly braces right here. So we're saying we're rendering image, instead of starting at 0, we're going to say starting at image 1 of the total render count, which we calculated up above. So it's this value right here. Then we want to calculate the seconds per render equals time.time minus start underscore time. Okay, so remember we figured out what the start time was up here. This is the current time. So we're going to get the time elapsed, essentially, and divide it by I plus 1, which is the number of renders that have happened so far. So obviously we would not want to start at 0 because then it would guess infinite time when we first started out. But what this will do is as more time passes and we've rendered more images, it's going to get a rough idea of how much time is left based on how long it has taken on average per frame so far. There's probably more elegant ways to do this, or more accurate ways, taking into account that it doesn't render the same amount of time every single frame, whatever. This is just a simple way that we're going to use to estimate how much time is left. So we're going to say seconds underscore remaining equals seconds per render times total underscore render underscore count minus I minus 1. Okay, so the amount that's remaining, basically you calculate the total render count minus however many you've done so far. So let's say we've done 10. That means we're on index 9. So we'll subtract 9 from, say, 18 in this case, because we have total render count of 18. That gives us 9. But we have to subtract 1 more because we're actually on the 10th image. So we subtract 1 more, we get 8. That means 18. After we've done 10, there are 8 left. Then we multiply that by how many seconds on average per render. So let's say it takes 1 second per render, then we have 8 seconds remaining. That's essentially what we're doing here. So now let's print it out. So we're going to print F, and then in quotes, we are going to say estimated time remaining, colon, and then in curly brackets, we're going to say time.strftime, and then we're going to pass in %h colon %m colon %s. In quotes like that, make sure those are capitalized. This is just how you format a time string into hours, minutes, seconds. And then after this second quote here, we're going to do time.gm time seconds underscore remaining. I know this isn't the most intuitive thing here. Make sure you close off your parentheses correctly and your curly brace. But this is how we're going to format the time remaining. And then we'd like to actually do the render. So we're going to update file path and render. So this one, pretty easy. bpy.context.scene.render.filepath equals, and this is where we get to take advantage of that path functionality right here. Because we're using a path and not just a string, what we can say is output underscore path slash, and then we can pass in whatever we want after this output path. So in our case, we're going to start at this folder, and then we're going to make a subfolder that is the split name. So /train / and then we need one that's the object name. So obj underscore name. And then finally, we need to give it a file name. So in order for this to work, we're going to do a formatted string, and we're going to make a number that is basically something like, I want to just show you, if we just start at 0, we're going to end up with 0.png, and then we'll have 1.png. It would be nice if all the file names kind of had the same number of, like something like this, because then if you sort them alphabetically, then they'll show up in order. Whereas otherwise, something like 2.png would show up before 14.png. So at least I think that's how it generally sorts them. So what we want to do is figure out how to create this sort of string right here. And there's a pretty actually straightforward way to do it. You basically just do str of some number. So we'll say 14 or 15 since I mistyped that. So we're converting the number 15 into a string, .zfill, and then you pass in some number, so like 6. And what this does is it just pads the number with some zeros. So that's what we're going to do. So we're going to do in curly braces, we're going to say str of I, which is the index that we're currently at, .zfill. We'll pass in 6. If you need more than that, you can go as high as you need to. And then finally, after the curly brace, we'll say .png. Now, there's one last thing here. We need to convert this to a string. So we'll say str and then put a parenthesis. And then at the very end, oops, we'll put another one. And so our full thing here is going to be a string of the output paths. So ABC test in my case /train /a/ and then the file name. Then we want to do bpy.ops.render right _ still, just like we did before, equals true. And that's it for this inner loop right here. We also need to hide the object when we're done with it. So we've gone through all of these. So we're going to hide the object. We're done with it. Okay, so make sure this is in line with this for loop, not inside of the for loop. And we'll say obj_to_render dot hide _render equals true. So this is almost completely done. There's just one last thing we're going to do at the end, go all the way back and outside. So this is not inside of the loop. We're just going to set all objects to be visible in rendering. And we're basically just going to undo this work. So I'm just going to copy this, where we hid them in the first place. We're going to put this here, and we're going to just set this to false. So this will make them all visible again. We should be able to save our script, and we should be able to press play. And Blender freezes up. So that might be kind of alarming, except that our output is moving. So it's moving just fine. And I just want to show you something. If you click in here, it will freeze it. So don't click in here. If you do, click enter, and it will resume. And so now we can watch the progress. It's outputting our last image right now. And now it's done. And Blender is responsive again, which is great. You can take a look inside of here. We still have this old thing because we don't have any code that deletes what's already in the folder, but it's not hurting anyone. Then we can look inside of our folder. We'll see that we have 3 subfolders here, A, B, and C. And we can look in here and see that it has generated new images for each one of these. So 0, 1, and 2, 3, 4, and 5. It's an interesting coincidence that it actually chose very similar colors for all 3 of those. But that's kind of how randomness works. In some cases, it's just going to look like it's not random at all, that something's broken, and other times it actually is broken and you need to fix it. So that's part of the reason why we don't just want to generate this many images. It would be a good idea to generate a lot more images and just verify that things look proper. So this is the point where if you want to, you can go up here and render more images. So what we'll do is I'll give you some suggested values and I'll let you go ahead and render out when you're ready. It might take some time. It'll probably take some time for me. So let me just show you really quick. OBJ renders per split. I'm going to set this to, let me see, what do I have here in my notes? Just make sure I do it the same. So we're going to do 300 training, 80 validation, and 10 test. So that's going to be 30 test images total, 240 validation images, and 900 training images that are going to run. And I want you to remember that when you run this, it will freeze Blender, and I have not found a simple way to make that, like, to break the frozenness. It's just gonna kind of go. If you start this off and you need to close it, then you can do so. You'll have to do that from the task manager. You have to close it the hard way. So just make sure you save before you run something that's expected to take a lot of time. And then you also might want to go in here and just clear this out, because it's not going to automatically delete these. It's just going to overwrite some of them, and some of them it'll leave behind if the numbering is different. So that's what we're going to do. Clear this out, and I'm going to hit play, and I'm going to take a look inside of here, and we can start looking at the estimated time remaining. For me, it sort of counts up a little bit until it gets a good average, and then it should level off and then eventually start counting down. So, and it looks like this will take another 22 minutes or so. So I'm going to let this run, and we'll come back and take a look at it when it's done. In this video, we're just going to take a quick look at the output dataset and make sure everything looks right. So all of the images rendered, 1,170 of them. So that's 900 training, 240 validation, and 30 test. So if we take a look at the output directory, so for me, that's abc_test in my temp directory. And I'll take a look in train, and let's open up A. And then we've got 300 items in here. And these are all the different colors and angles of A. Now, some of these you'll notice, they're not super obvious which ones they are. So that will be an interesting challenge for our neural network. I never feel good creating a data set that doesn't really contain any challenge in it. So, if it was trying to tell the difference between a bunch of red A's, green B's, and blue C's, then that wouldn't be very challenging. It would just need to learn how to tell the color apart, for example. So, making this an interesting challenge is what makes this a good learning experience. So you'll find some in here. You can take a look at the different ones. Just make sure everything looks like it's well represented, that nothing seems to be off screen, or the color doesn't change or something like that. When you have a large number like this, you'll be able to rule out cases where it looks like you got a bunch of the same thing in a row or something. So make sure your training set is ready. It'll be, in this case, we need the train, validation, and the test data set, because we're going to be using this to run our test. And then we'll come back in the next section and we will train an object classifier on this data set.